Hi guys, let us discuss depth first search in graph data structure. So what is DFS? DFS starts at root node and explores the branches in depth as far as possible in each branch before backtracking. The purpose of this algorithm is to search and mark each node or vertex as visited. Let us see the example for DFS, then you can easily understand the DFS algorithm. Let us see an example for DFS, depth first search. You consider this graph where there are nodes A, B, C, D, E, F, G and H, and we are to prepare adjacency list for this graph. So what do you mean by adjacency list is, suppose you consider node A. For node A, you check what are the nodes are connected with A with one edge. So for example, if you take A, it is connected with B and C with only one edge. So I will consider B and C as adjacent to A. So for example, if we take B, so what are the edges having the connection with the B, and the nodes are A, D and E. So that is why adjacency list A, D, E. Suppose we take C, so now you have to check the nodes that are connected with this node C with one edge. So A, F, G. That is what the adjacency list for C. So for D, the nodes that are connected with one edge with the D are B and H. That is what's given here, B and H. For E, you see there is only one node B, it is connected with one edge, so adjacent is B. So for F, there is only one node C connected with one edge C, and for G there is only one node connected with one edge, that is C. So C is the adjacent node with G, and for H only one node D is connected with one edge, so the adjacency list for H is D. So this is what the way to prepare adjacency list for a graph. So the first job is to prepare adjacency list for the given graph. Let us start with the source node A, and we create a list called as visited node. So in the visited node list, you mark A as visited and enter into this list. Then you enter this node A in the stack. So what is a stack? Stack is a data structure which follows the last in first out. So you enter the node A in visited node list and also in the stack. So what is the next step? You refer the adjacency list of A where you find two nodes B and C are adjacent to A. So now I have the choice to choose B or C, but I choose B because we follow alphabetical order. You can choose C also. If we choose C now, the DFS order will be different. So it's better or advisable to choose the nodes by the alphabetical order. So as you choose B now, so what you have to do? So you have to enter the B in the visited node list and also in the stack. That is what we have done. So we have entered into the visited node list and also in the stack. So now we refer the adjacency list of B where you find A, D, E. So when you refer A, it is already available in the visited node list. So you should note down that if a node is already visited, you should not consider it again. So now I go to the node D. So node D is not available in visited node list. So you enter the node D in visited node and also in the stack. So that is what we have done. So now we refer adjacency list of D. So what are the nodes you find? B and H. So B is already available in the visited node, but H is not available in visited node. So what you should do? So you should refer H next. So you put the node H in the visited node list and also in the stack. So now you refer the adjacency list of H. So when you refer the adjacency list of H, you find only one node D, but the D node is already visited. Okay, that means there is no further node after H. So now what you have to do? You have to remove the node H from the stack. So once you node H is removed, and also we found that there is no further node to be visited which is directly connected with the H, because H is connected with only D, but D is already visited. So now we have to remove the next node from the stack, that is D. So you remove D. When you remove D, now you refer the adjacency list B and H. So B and H are adjacent to D, but B and H are already available in the visited node list. That means you remove the next node from the stack, that is B. So when you remove B, you find the adjacency list A, D, E. A is already available, D is also already available, but E is set to be visited. So we enter E in the visited node and also in the stack. So, but there is, when you refer the uh, adjacency list of E, there is only one node B which is already visited. So E is removed now. Now, next you remove the node A. So when you remove node A, you find the adjacency list B and C. B is already visited, but C is set to be visited. So enter C in visited node and also in the stack. So once you enter into the stack, now we refer the adjacency list of C, A, F, G. A is already visited, but F is yet to be visited. So now enter F in the visited node list and also in the stack. So once you enter F in visited nodes and stack, now you can remove the F from the stack because there is no further node to be visited. It is directly connected with F because the adjacency list of F is C, but C is already visited. So now you remove the F, then what is the final node? C again. So you remove the C also from the stack. So when you refer the adjacency list of C, A, F, G. A is already visited, F is visited, but G is yet to be visited. So you enter G in the visited node list. So as you have visited all the nodes of the graph, then we can complete this DFS search. So as per the DFS search, the order of the nodes visited is A, B, D, H, then E, C, F, G. That means we go by the depth first search. That is what the purpose of DFS.